All right, and we live. Take it away, Nicole.
Is it live in YouTube already? Because I'm not seeing it. Okay.
It is. There's a 20-second delay.
All right.
Well, there we are.
Hi, everyone. Welcome to our community office hours today for Consul, where we're going to be talking about Consul and Kubernetes. So to get things started, I'm just going to kick us off with a little bit of a demo to show Consul being deployed into Kubernetes and then deploying services using the service mesh features of Consul. And so one of the things, let's share my screen. All right, so one of the things we're going to use is our Consul Helm chart. And so this here into the terminal data center name to Nicole Lab, just install this with Helm. That this is starting. Oh, we have to change is the server called something because for the servers defaulted to 3 on my laptop.
We're not actually streaming right now, Nicole. Should we keep going, Alex?
Yeah, hold on.
I just showed it popped up in YouTube, but it's way back at the beginning.
Same.
Oh, okay.
Yeah, it says we're streaming. Of course, we're getting these errors. I moved just in case there was an issue with my Wi-Fi. I'm still seeing an error here. Bear with us for one moment.
So the HashiCorp channel did just switch to say live. So that's a progression on my end.
Okay. So I would say,
The YouTube stream shows my console now.
yeah, I would say we can pick up where you left off, Nicole. I think we are just ending up that the live stream is going to be a little bit behind, but the content is there.
Okay, perfect. All right, so now that we've edited our values file to have only one replica, we can go ahead and redeploy this. And now we can check it out again. And we can see we've got our console client running, our connect injectors running, and we're creating our servers. So if we just give this a minute, those will all come up. You can see now our server is running and ready. Now, if we just give it one more second, we'll see our client come online. It just has to wait for the server to completely start and then reconnect. And there it is. So now all of our pods are up and running and the ready state is successful for all of them. So now what we can do is we can deploy our counting service. And so what this is just a very simple pod that runs our counting service container that we've created. We give it our service account so that it's counting. And we give it an annotation here, this console.hashicorp.com connect inject true. And so this is what we enabled. And this tells that mutating webhook to automatically add our proxies to this pod, even though we've only specified a single container. So we can go ahead and create this. And we can see now that the pod has been created. So if we actually describe that pod that we created, we'll be able to see up here that in our containers, we now had an init container added for us that does the console connect inject initialization, which configures everything for us for the proxy and our checks and services and everything that we need. We bootstrap everything and then we actually start our containers. And so here we have our counting service container that we defined. And then we can see we have another container running, which is the Consul Connect Envoy Sidecar container, which is running our Envoy proxy container for us with the config that we've properly configured. So if we take a look at kgit pods, we can actually see we have counting and there's a total of 3 pods or containers running within this pod. So now to be able to talk to this, what we can do is we can actually take a look at our dashboard service. So here we're going to do the same thing. We're going to deploy a pod named dashboard. We're setting connect inject to true, but now we're also setting an additional flag for connect service upstreams. And so what this does is this allows the proxy running for this container to create a local host listening on 9001 that will connect to the counting service through our service mesh. And so then we can define our dashboard service, and we can tell it that the counting service URL is actually localhost 9001. And this will send all of that traffic through the proxy, secured and authenticated. And then we go ahead and define a Kubernetes service that creates our dashboard listening on port 80 and target port 9002. And so let's go ahead and create this. And we can see we've got our dashboard pod initializing. If we give it just 1 second, we can see now that our dashboard pod is running. So now if we take a look at our services, we'll see we have our dashboard service load balancer, and we can actually do a port forward on this. Let's see if I can remember this off the top of my head. Service load balancer, 80 to 8080. Oh, what did I get wrong? Actually, I need to specify something.
Remove the get.
That would explain it. Oh, I've got my ports backwards. Oh, yeah, 8080 locally to port 80 remote. There we go. So now listening localhost, we're forwarding to our service. So if we jump back over here, we can actually see that on port 8080, we have our counting service, which is talking to our dashboard. And so now some other things we can do. There we go. Let's go ahead and get our services one more time, and we can see we have our console UI. So let's go ahead and create a port forward for that, so that we can access our UI for console. And that's listening on 80 also. So let's put it on 9090 to port 80. And so now we can access that. So if we come over here and we access localhost 9090, we'll see our console UI, and we can see that we have all of our services. So we've got console, we've got our counting service, our dashboard service, and their sidecars, our data centers, Nicole Lab, which is what we specified in our file. We can actually come over and we can create an intention if we want, and say we wanted to secure our network and actually block traffic between everything. So we can just create a generic rule to block all traffic. And now if we jump back over here and we look, we can see that the counting service is unreachable. Pretty instantly, those intentions start applying and you're not able to see that. And then we can come back and we can create another service rule that says the dashboard is allowed to talk to the counting service. And once that's applied and we jump back over, we'll be able to see it's already connected and working again. And so that just shows you some of the things you can do to secure your network with the service mesh, as well as secure the communications between your services fairly easily inside of Kubernetes, and how easily you can deploy the console Helm chart to get a working console cluster. So now we've got Luke and Blake from the consoles teams. I'll let y'all introduce yourself.
Hi, my name is Blake Covarrubias. I'm a product manager on the console team.
Hey everyone, my name is Luke Kaiso, and I'm an engineer on the console team that focuses on our Kubernetes integration.
Awesome. All right, so everyone in the stream on YouTube, feel free to ask any questions as you have them, and hopefully we'll be able to answer them for you. But while we wait for some questions to start coming in, Blake, do you want to talk about some of the common questions that you get asked around console and what your answers are to those?
Yeah, so I think some of the common questions that I see are folks that are really trying to understand how do they migrate over to a service mesh? Do they need to be all in on Kubernetes, or do how do they make legacy applications available into the service mesh? And so one of the unique kind of differentiators of Consul versus other solutions in the market is that Consul is multi-platform and multi-runtime. So, what we're showing today of deploying sidecars for services in Kubernetes, you can also deploy those sidecars or proxies on virtual machines or bare metal services and allow those to natively participate in the mesh. So you don't need to kind of go all into Kubernetes or re-architect your applications to containers in order to take advantage of Consul Service Mesh. You can deploy Service Mesh on your existing infrastructure and existing monolithic applications where you are today, and then gradually make that change or migration over to Kubernetes, if that's where you desire to go.
That's awesome. What about you, Luke? What are some of the questions you usually get asked?
Yeah, so a lot of people are running Consul like outside of Kubernetes, and they've been, they have companies that have been around for a while. That was kind of the de facto service discovery technology you would use. And then they're starting to deploy stuff into Kubernetes. And I think a question a lot of people have is like, okay, well, I have Consul running outside. How do I still want to talk from the stuff running outside Kubernetes into Kubernetes and vice versa from Kubernetes running out into Consul? How can I leverage Consul? If you didn't have Consul, what you can do in Kubernetes is you can create an ingress gateway, ingress controller. And so your services outside of Kubernetes, they can talk to the ingress controller, but then you need to kind of hard code all the routes somehow over into your stuff outside of Kubernetes. And then from inside Kubernetes, if you want to talk out to your stuff outside of Kubernetes, you can create external name services in Kubernetes that route to like a DNS or an IP address, and then you can use kubedns to route back and forth. But you have to manage all these things manually. And so this is kind of like where Consul is really useful in this use case. So if you already have things registered in Consul outside of Kubernetes, we provide a way where you can, it's called a catalog sync. So it's syncing the catalog of services both into Kubernetes and from Consul into Kubernetes, and also from Kubernetes into Consul. And then it allows you to use the same service discovery mechanisms that you're used to either in Kubernetes or outside of Kubernetes to talk between the two. So a concrete example is if I have the foo service running outside of Kubernetes and I have the bar service running in Kubernetes, then you can run this sync catalog service, and it'll take the services that are running in Kubernetes and it'll register them into Consul. And then when you're running outside of Kubernetes here, if the foo service wants to talk to the bar service, it can use regular Consul DNS and it can just talk to the bar service that's in Kubernetes, and vice versa. We sync the foo service into an external name service inside of Kubernetes for you and automatically update like the IP and all this other stuff. And so when you want to talk outside of Kubernetes, you can use Consul DNS or you can use kubedns, and that will route all the way out, and it'll keep all those things in sync for you, which is kind of the whole point of a service discovery. Is it's dynamic and it keeps everything up to date. So that is very basic, like a good way to integrate between things that are running outside of Kube and things that are running in Kube. And then if you want to go a step further, then you can bring on the service mesh, where you're registering these things and stuff that Nicole was showing, where you're getting like TLS between all the different services because you have all these proxies wrapping everything. That's kind of like the next step there. And you can create like custom routing rules and splitting traffic and kind of all that good stuff. So that's kind of like the next step there.
Awesome. All right. Blake, any other questions you get asked?
I think one that comes up often is how does Consul enable kind of cross-cluster or multi-cloud connectivity? It seems to be a challenge that a lot of organizations are looking to solve. Typically, when they have a lot of on-prem applications running within a physical data center, but they're looking to move to the cloud and utilize something like AWS, Azure, any of the public cloud offerings out there, and they have a need to connect those services across those different environments. How do they do that? And today, the way that they would typically do that is by standing up a VPN to that remote cloud provider, or using a direct connect solution, for example. But those can be costly and can be difficult, kind of to manage at scale. And so, Consul can provide that service-to-service connectivity between data centers using something called mesh gateways. And what this allows is, this really allows you to extend your service mesh in a more native manner across different data centers, and while retaining end-to-end encryption between service-to-service traffic. So you don't have any decryption, re-encryption of traffic that's happening. You're able to deploy these gateways, which sit at the edge of your data center, kind of straddle your LAN and WAN. And then when service in these on-prem data center needs to talk to something in the cloud, it can be routed through that gateway and forwarded to that remote DC. And so I think that's what comes up often. There's a lot of interest in that in general in the space, and multi-cluster deployments. And I think Kubernetes as a whole is relatively new or gaining maturity in multi-cluster deployments. And so folks are understanding, how do we fit in with that? How do we enable this with the context of service mesh?
Awesome. I know from my side, playing with mesh gateways and actually using them some, one of my favorite features with them is the ability to actually have overlapping IP space at different providers, and for the mesh gateways to handle all of that NAT translation between those, so that your services can be in the same IP range, so that if you have existing infrastructure where there's IP overlap, you can still enable that communication between them. All right, Luke. Oh. Okay, it looks like we have one question. What are the differences between Consul intentions and some of the other network policy capabilities in Kubernetes?
Yeah, so the network policy is a Kubernetes kind of resource that you can set that does basically the same thing as intentions, where it will stop requests from one pod to another. The thing with that is that it requires that you have a CNI plugin that is actually implementing it. So something like Calico, or I think Cilium does it too. So that's kind of like a big step, I guess, to add to your cluster. And so some folks that are already running their cluster, they might not want that. So that is kind of like either at the IP tables layer, or it's like at some even deeper layer, like a eBPF or something like that. But at the console layer, it's just done right at the proxies. And so it's kind of like conceptually, it's a little bit simpler to think about and to reason about. If there's something goes wrong with it, you don't have to like dive into IP tables. You're just more looking at like at Envoy or something like that. So I think like at one point, that's kind of one of the biggest differences. The other thing is that it works multi-cluster and multi-platform. So if you are having stuff on your on-prem DC and you have stuff running in Kubernetes or in a couple of different Kubernetes clusters, intentions will work all across those. They're going to work across, like if you're federating across the public internet or whatever, intentions are always going to work there. So with the network policy, it lives like it's a cluster specific thing. It lives in the cluster, it's cluster scoped. And so with Consul intentions, because they're kind of across all of your data centers, you kind of get that global traffic policy there. So I think those are the key differences. I don't know if you have anything else on that, Blake or Nicole.
I'll add a little bit. So from my perspective of interacting with both of these, one of the big things I've noticed is when I'm defining Consul intentions, I'm specifically defining which services can communicate, or that this service can communicate with any other service. When I'm doing Kubernetes network policies, you're doing pod selectors to match labels, or namespace selectors to match a namespace. And so you don't get like this specific service. It's anything that happens to match these labels for the container running will be allowed to communicate. But if someone accidentally messes up the labels and all of a sudden you've defined your label for role, say app, and now there's two services that have role app, but also another label that differentiates them. If your network policy doesn't have that, then both of those services can now talk to the other service. So the complication of trying to make sure all of your labels match and don't overlap, and that you are specific enough in your labels, gets to be a challenge Whereas with intentions, it's just straight, this service can talk to this service. And I like that more direct approach versus the more generic approach. You have anything you want to add, Blake?
I think you both covered, I think, primary points and differences between network policy and intentions. Maybe just a clarification to add is that policy is really enforced at the network layer, whereas intentions are more of an application, enforced application layer. And then, as Luke and Nicole mentioned, that intention and that service identity is kind of propagated between different clouds and different environments. And so you're not really reliant on what is my cloud provider support or what is my infrastructure provider support in terms of, can I use network policy within this environment? This is implemented at a higher level where it's not dependent on the actual cloud infrastructure. And so you have a more consistent policy mechanism that you can use across the different runtimes or clouds.
Yeah. All right. It looks like we have another question, which is, do I have to package the console binary with my application containers? Do you want to go ahead and take this one, Luke?
Sure, yeah. So the short answer is no. So depending on what feature you're using, if you're using the service mesh feature that we talked about, we handle, when you submit your deployment to Kubernetes, we have a webhook that handles, it reads that deployment, it reads the pods and actually injects the sidecars for you. And that's kind of what Nicole showed at the very beginning there, where you could see like there was different, you submitted a pod with one container, but when it came up, it was actually running more than that. And those are the containers that we're injecting for you. So in that case, you don't need to have the console binary at all inside your container. Your pod, all the containers in your pod, they run just as normal. We don't do anything to their file systems or anything like that. They work just as normal, and we're kind of adding sidecars around the edge that can then intercept traffic and do the registration to console for you. And then same for if you're using the catalog sync feature, we're running like our own deployment. This is watching the Kubernetes API. And when services come up, we notice them. And when they get updated, we notice that update. And then we just updating console directly. So again, you don't need to have anything in your application that's specific to console.
Yeah. Do you want to add anything to that, Blake?
Yeah, I think so. There are console clients that are deployed on all of the Kubernetes nodes within the environment, but those are deployed as a daemon set. And so there's one console client for that entire host. You don't need to have a console client specific to each application running on that host.
Awesome. Yeah. Looks like we have a follow-up question there, or another question. I saw some layer 7 features that allow me to split traffic to different applications. Can I use these features to do A/B testing between applications in different Kubernetes names? I'm gonna guess namespaces is the question there.
Yeah, so yes, you can. You'll be registering those services. They'll get automatically registered into console. And then in the L7 rules, you can just like pretty complicated, all the stuff you can do there. So you can definitely do things where you route specific traffic based on like a header or a specific like subset, like amount of traffic that you want to route to different services. And that will totally allow you to do what you're looking for with the A/B testing. So yeah, it's totally doable, and it's a really great use case for Consul Connect. And if you can imagine like how you would have to do this without the Consul Connect, you would have to basically edit the code of all the different applications involved in this and actually do redeploys for them, or have them like call out to your magic A/B testing service and kind of dynamically reconfigure the routes. So that's kind of one of the beauties of the service mesh is you have all these proxies running everywhere. They're centrally configurable, and with like one fell swoop, you can configure all the traffic across all your applications. So I think that's kind of where the service mesh really shines is with these use cases.
That's awesome. Do you have anything on that one, Blake?
I think, Luke touched on it. You can also, though, in addition to doing splitting between namespaces, you can also configure console to redirect or send traffic two services that are running within a different cluster. If you want to do that as well, if you have a need to redirect or something, parts of your microservice or percentage of traffic to a different cloud environment that's supported natively within Connect.
Yeah, and this is one of my favorite features, is the ability to split traffic and do things like this. So like when you're deploying, say, a version 2 of an API, you can actually start testing traffic with like a 20% split to see if there's any issues with your existing clients and things along those lines. All right, doesn't look like we have any additional questions yet. So if anyone has any, feel free to ask. While we wait for any additional questions, Luke, what's your favorite feature of Consul?
I think I have to say that the service mesh is, when you get it all working and set up and configured, it's really, really kind of mind blowing. I can definitely talk about one of my favorite upcoming features. I don't think this is spoiling too much, but basically, we have this ability to do federation. So between, like, say you're running a cluster on EKS and a cluster on AKS or something, right? We have this upcoming feature that's going to make this a lot easier to do. And you can basically do it in like 4 steps. You can set all this up. You can have stuff routing between EKS and AKS and like GKE. So you can have like this multi-data center, multi-different like cloud provider federation where you can do routing in between all of them. You can configure like failover for multi-DC failover. You can configure traffic splitting. It's just really incredibly powerful. And the cool part is that each app just doesn't even know that this is happening as far as it's concerned. It's just talking out to its dependent service. But under the hood, like, we're literally like proxying all this stuff over the public internet. It's totally secure. You can set intentions between everything. So I think that's like one of the coolest features that we have coming up, because it just works so seamlessly. But like, if you understand what has to happen under the hood to make it all happen, it's pretty crazy. So that's something that I'm really looking forward to.
Yeah, I think kind of related to that, from my perspective, another upcoming feature that we're adding is a feature called terminating gateways, which provide the ability for applications running within a service mesh to connect to legacy applications or services that are running outside of the mesh, where it's not possible to have a sidecar deployed on that application. And so I think that's really exciting, because it allows you to do things like have web services or APIs running within the pub cloud, but maybe these need to call back to an on-premise database. They can use the mesh gateways to go between the different data center environments, and then egress that service mesh on-prem to talk to that legacy service. And so what that would provide you is kind of end-to-end, mostly end-to-end security for that application communication, and provides you a way to expose those legacy services or into the service mesh environment. So I think that's really exciting. There's a lot of different enterprises, with use cases for that, and I'm really looking forward to that upcoming feature.
I have to say, these 2 features coming out are 2 of my favorite features that I'm really excited about, because 2 of the questions I get asked most often is, how do I connect my Kubernetes clusters together with Consul? And the other one I get asked a lot is, how do we secure access through the mesh to my database as a service that I'm using from my cloud provider? And so it'll be really awesome to be able to leverage these 2 features to help solve those problems. So what tips would you give to someone looking to get started with Consul?
Yeah, so
Do you want to take that one, Blake?
Sure. Yeah. So I think we have a large number of resources to help people really get started with Consul. A lot of that content can be found on learn.hashicorp.com. There's a lot of great guides for understanding just Consul service discovery, and then kind of building into Consul service mesh, either on VM-based platforms, bare metal machines, or in the context of Kubernetes. I'd recommend definitely checking out those resources, because they'll help you kind of grasp the fundamentals of how does Consul work, and then you can slowly build onto your knowledge, start actually deploying Consul sidecar proxies, configuring service-to-service connectivity, and then doing more advanced things like routing based on HTTP information, traffic splitting, and then eventually some of these multi-cluster, multi-cloud features that we talked about as well using mesh gates.
Anything you want to add to that, Luke?
Yeah, I think, we have so many resources out there in terms of our learn guides to get started. You can get started kind of on Minikube with, most of the security features turned off, so you can just play around with things. But then from there, you can kind of go up in complexity, and you can start about federating multiple data centers. You can add in TLS and ACLs to actually have everything actually fully secure. So kind of I would recommend starting small, messing around with things on kind of Minikube or whatever, and then kind of going up in complexity from there. And yeah, that's kind of how I would recommend getting started.
I think another avenue though that's also available is if you're looking for something that's a little more instructor led, or something where you can bounce questions off subject matter expert while you're trying to learn Consul. We do have workshops that we run. You can find these on events.hashicorp.com/workshops. And there's various workshops on a number of different products, but there's definitely some coming up for Consul that you can register. And these are all happening online that you can participate in. And those are instructor-led workshops where you actually go through and are given tasks to deploy various features of Consul, and you're able to actually kick the tires on it and then ask questions in real time if you want to understand in a little more detail how something's working, or you get stuck along the way.
Awesome. I believe Jono has a question actually. So Jono, if you want to go ahead and ask.
Yeah, so a lot of times I've found customers are trying to look for a secure way to update their service mesh or be able to administer their service mesh. Do you have any recommendations or tips or tricks for how to leverage CI systems as a one-stop shop for really expansive developer teams to interact with their service mesh?
Yeah, I can take a stab at that. So I think there's obviously lots of different ways to do it, but one way to do it is, you have your dev Kubernetes cluster. That's totally open, and developers can use kubectl or whatever they want from their laptops to access that. But when you start talking about your production Kubernetes cluster, you might have read access from your laptop, but you don't have edit access, you don't have write access. And so the CI system has, it has the kubeconfig credentials basically that allow it to do writes. You can get fancy, you can put that into Vault and everything like that. But in general, that's one way to lock it down, is the Kubernetes cluster is the only one that has the Jenkins cluster that only has the ability to deploy to the Kubernetes production cluster. And then because the injection happens automatically, when you submit those pods, they're automatically going to be injected with Consul. So you don't actually do anything extra in terms of security around that injection. And then when we talk about setting up routing rules and intentions, so with intentions, you can do that through the UI or through the CLI, and Consul has its own ACL system to handle that. So you can make sure that that the ACL tokens are kind of secure. And again, the dev cluster is wide open, but in production, only specific people can actually set up intentions and around different services. And then the same thing for creating these L7 entries. So the ability to create those is behind a separate ACL rule. And again, you can kind of gate that depending on the environment and the security there.
Awesome. So one of the questions that kind of flows with this one, I think, that came in from YouTube is, what are your favorite tips and tricks when you're testing something on or deploying to Kubernetes? So do you want to take a stab at that one, Luke?
Delete the PVCs. So the way Consul works is the Consul servers actually have a state. And And this lets it run both in Kubernetes, but also off platform in a different platform where there is no magic etcd storage always being there. And so one of the results of this is we use persistent volume claims. And one of the downsides with Helm is it doesn't clean those up when you delete your Consul cluster. So if you're just messing around with it and you want to do like a clean restart, like the number one tip is to delete the PVCs afterwards, so that they don't stay around, because if they're still around and you reinstall, everything gets really confused because it has like IDs that don't match what is actually running. It's like if you have like two different services and you switch their databases, they'd be really confused. And so that's kind of my number one tip, is to delete the PVCs.
Yeah, that one caught me. I was doing a demo and I was setting it up and I did a run through of it and I was playing with intentions and stuff and then wiped everything away and then came back time to do the demo and like all my intentions are already there. And I'm like, how'd those persist? And I'm like, oh yeah, the PVCs don't get cleaned up. So yeah. It looks like our next question is, I'm exploring Consul's key value feature as configuration as a service for our distributed microservices. Are there any heads up for me to start with? Do you want to take that one, Blake?
Yeah, so I think that's definitely, a use case that we've seen for Consul, and a fairly popular one for some enterprises. I think if you're looking to get started with it, probably some of the easiest way to utilize Consul is if you're looking to say update application configuration. There's a tool called Consul Template that we provide that's able to connect into the KV store. And basically you can write these templates that can utilize either service discovery or key value data, and then update configuration, say in an Nginx configuration or HA proxy config if you're trying to update backend, load balancer pools, or maybe you just want to have a configuration setting that you can toggle in mass throughout, a set of web servers or application servers. You can use Consul Template for that process to monitor those keys, and then when they change, update those configs in real time and reload that service to pick up the change. So I think that's a much easier way to get started with KV and to realize some of the value of it versus using an SDK and kind of coding the KV functionality into your application itself. That's definitely available. There's a lot of SDKs in multiple languages that would allow you to do that, but if you're looking for a low friction way that doesn't require a lot of code changes, a Consul Template is one way to do that.
Nice. Anything to add to that, Luke?
No, I think that's exactly right. One thing I've learned over time as an engineer is you really want to avoid coupling to specific technologies. And so you want to focus on like the workflow, which is like, I want this config file to be updated, or I want it to be dynamically generated when I start my service. And the best way to do that is to run something ahead of time that you can swap out later if you want. So this is like Consul Template that just writes the config once, and then your app is just reading that config. I would recommend that over like having like the Consul SDK running inside your app and like pulling that itself. And if you want to get dynamic updates, then you can watch like the file system and get like the iNotify or whatever it is, and kind of like re-hop on that. So that's kind of like my one pro tip on that.
Awesome. Yeah, it looks like someone just posted a tip in the YouTube channel to be a bit careful when you're writing your loops, because depending on the stuff in your key value with Consul Template, they managed to set it up in a way that had Consul Template watching over 700 dependencies. So that's apparently something you want to watch out for. One other question that came in from YouTube was, have y'all tried Shipyard? So it's a tool created by Nick and Eric from the Developer Advocates team. And have you had a chance to play with that? And what are your thoughts on it?
So I actually tried it for the first time over the weekend. Nick did a demo where he was exploring using WebAssembly with Consul and use Shipyard to set up that development environment. And so I wanted to kick the tires on WebAssembly and use that as an easy way to kind of get started. I found it much easier to use, I guess, than deploying or standing up a Consul cluster myself, and then using the Helm chart to deploy and install Consul. It was easy. Just I forget what the code was: shipyard up, shipyard init, something. But I had full functioning environment, and so I can't say that I have a lot of experience with it. But it did make that pretty straightforward to get started with. So far so good. I'm looking forward to getting more hands-on with it in the future.
What about you, Luke?
Yeah, I've definitely messed around with it. I think like my favorite thing about it is it's messing around with Docker containers. So it's kind of orchestrating Docker containers versus running like a VM, like Minikube is, or at least was last time I checked. I know they have a bunch of different ways to run it, but I find that makes it like a lot faster to start up, and you can do a lot of like kind of cool, complicated things, but you're not dealing with a bunch of weird virtualization kind of layer in between everything. And yeah, I'm definitely looking forward to using it for some of our more complicated like learn guides where you're running multi-cluster. I mean, I know a lot of people don't want to like spin up, clusters in GKE and EKS and AKS, test things out. It's expensive. It's not easy. Often like the setup process is actually quite difficult, and to get the cluster running the very first time, setting up service accounts is just like a really big pain. So I think it's really, really cool for those kind of tutorials.
Nice. So I've used it some myself as well. And the thing I like about it is I think about it kind of like Terraform. I get to define everything as code. So instead of having to remember, I need to run this Helm command to install this Helm chart and then deploy these YAML files, like I can put all of that in code and just do the shipyard up and automatically get all of that deployed into my cluster so that I have a demo environment ready to go that I can show features in. So that's one of my favorite features of it. So what are some of the other questions you guys get asked regularly?
I can go.
Yeah, go ahead.
One question we get asked is a lot about deployment topologies. So it's like, hey, I'm running, I already have a set of Consul servers, so I don't want to run them in Kubernetes. Or I'm running everything in Kubernetes, but I have like this one VM, and I just want to run like a Consul client on that VM so it can kind of integrate with the mesh. Or yeah, so those are kind of like the questions we get a lot about. And the answer with all this is like, it's complicated because networking. But one thing that's like one thing I think that trips people up is the way that Consul works is all of the clients, they're all gossiping with each other. So that means every client is talking to every other client. And this is really, really powerful because what it lets you do is detect failure really, really quickly and have that gossiped out. So basically like have that information kind of propagated randomly out and really quickly. So when you have like thousands and thousands of nodes, if you can imagine like there's one server that's basically just like checking everything, then that's going to be a lot of noise. It's going to be like a huge traffic issue. And it could be wrong because this one server can't reach this node, maybe that other server's down. So that's one thing that trips a lot of people up, is that all the clients need to be actually able to route to one another. But if you can get that working, if that can work in the setup that you're looking for, then all those different topologies are totally deployable, and they're really, really, really powerful. I think a lot of people like to run the Consul servers on VMs. If you're like a really big Consul user, you kind of want to have more control over that. Running stuff like stateful things in Kubernetes totally works, and there's a lot of people doing it. But there is a little bit of dragons there just because you're running on top of stuff. So that all works. It's all documented on our website about how you can set up these different topologies. If you look under the Kubernetes docs section, you can see like there's a bunch of different topologies listed there.
Awesome.
Hey, Luke, I have a question real quick. I've dealt with some instances where, let's say, someone set up a Kubernetes cluster and they gave themselves the cluster admin role binding on their token. Are they able to see the traffic going back and forth between services in the service mesh?
If you have cluster admin access, then yeah, because you could exec into any pod and run like a TCP dump. Maybe you couldn't if like the containers were set up with like pod security policies that didn't let you run TCP dump. But in general, like if you have cluster admin access, then you could spin up like your own pod that has the same name and then you could capture the traffic that way. So yeah, in general, like once you have cluster admin access, everything in your cluster is open. And that's not specific to Consul. It's just the way Kubernetes works. It's like if you have cluster admin access, you can basically do anything you want. So that is something you want to be careful about what you're doing there. Namespaces are kind of like the Kubernetes way to handle this. So, a team has a namespace or they're only allowed access to certain apps in that namespace. And so you can kind of scope down the role to that using the RBAC permissions. So that's kind of the direction that you probably want to go there.
So there's no substitute for having good Kubernetes best practice for cleaning up your role bindings or things like that.
Yeah, I think like if you look at a lot of the Kubernetes security flaws, some of them are like this privilege escalation where you have like a Docker image that's like a bad one, and somehow it uses a way to get like cluster admin access or whatever, and now it can access everything. So yeah, there's like, we don't protect against that. What we do protect against is, because all of the traffic between the pods is encrypted, if you were maybe like on the node and you were being able to listen to that traffic that's coming out of the pod or whatever, you wouldn't be able to see anything. So it was all encrypted. And so that's kind of where it's really powerful there, is if you are able to see like traffic flow, I mean, of course, or across the internet or whatever, you can't intercept that. You can't in the man in the middle of that. So that is where kind of this added security does come into play.
Yeah, it's more protecting traffic in flight. Consul isn't really a replacement for just general good security practice of making sure your hosts are locked down and patched and have appropriate ACLs or whatever configured on the infrastructure platform that you're using.
Awesome. We are getting close to time, so I have one last question that I want to ask. So Luke, if I'm deploying Consul into Kubernetes using the Consul Helm chart, what are some things that I should do to make it ready for production, or are the default values already ready for production?
Great question. And I know there's also a question in YouTube, so we'll make sure we get time to that too. So the default values are not everything you need. Generally, the way HashiCorp tools work is we make it easy to get started and mess around with things and try to have a good first experience. But then if you want to set everything up to make it all production ready, like there's additional steps you have to go. So there's a guide on our Learn guide called reference architecture, Consul reference architecture. So that has a lot of best practices for how to set up your production ready Consul cluster. And I think the key things that you need to have are TLS enabled, and you need to have ACLs enabled, and that's going to really lock things down. That, and then you want to make sure that the resources are sufficient for your Consul servers, so that they have enough CPU and memory to actually operate properly, depending on the size of your cluster and how many services are registered. Those are kind of the main things that I think are really important to get right when you're doing your production install. And then the question on YouTube is, I really want to set up a mesh over our different VPCs and with a leg in the DC that does legacy connections to our customers, DCs being on-prem stuff. So I'll talk about in generic, I want to set it up between my different VPCs, and then we'll talk about the leg part. So you can definitely use the federation capabilities of Consul and mesh gateways to connect between different VPCs. They enable connections between totally overlapping IP spaces, totally non-routable IP spaces. So that's what you'd be looking at there, is because if you've peered the VPCs, you could actually maybe get away with a shared Consul cluster. But in general, we'd recommend a cluster in each VPC, and then you can route between them like that. And then for the leg over to your private DC, Again, we'd probably recommend running a separate cluster in your private DC or your on-prem DC, and then having a mesh gateway that routes in between those two. And so the only thing that needs to be like exposed on the edge or routable between the two are these mesh gateways. So they need to be like routable either by like an IP address or a DNS entry that can connect between the two. I don't know if you're using direct connect or what exactly you're using there. But yes, it is totally doable.
It looks like there was an additional comment made there with different VPCs should be fairly straightforward with peerings already being set up, etc.
Gotcha. Yeah. So if you have it like fully peered, then you don't necessarily have to run a different console cluster per VPC. But in general, that is usually the way to go, because that's kind of like the best way to model these different, like if you're thinking of them as data centers, then I think you should have run separate console service clusters in each VPC. If you're thinking of them like, hey, I have this like mega VPC and I started A and then didn't have enough IP space, so I added B and they're peered now. But to me, they're basically the same data center. Then you can run just one console cluster in there, and you're good.
So it looks like we had one more question come in, which is, in a cybersecurity field, which is commonly used, Docker or Kubernetes?
Yes.
That would be my answer as well.
So I guess it depends on exactly what this user is asking, but you can use, maybe they're meaning like Docker Swarm or Kubernetes, because the way Kubernetes works is like the way it runs its containers on each node, the thing that's running the containers, they're still Docker containers. So it basically like Kubernetes is orchestrating Docker across all your different nodes. So if you're using Kubernetes, unless you've switched out the container runtime, you technically are using Docker as well. But if they're talking about Docker Swarm versus Kubernetes, I think most people are using Kubernetes, like a very high percentage.
Yeah, in my experience working with customers and seeing what they're doing, most are using Kubernetes. The cases where they're using Dockers when they're wanting to run something in a VM for either persistent storage or other things along those lines. And so then they might use Docker containers just to keep the configuration a little easier in setup. But usually they're wanting the orchestration features to go along with those containers. All right, well, we are almost at time. So I'd like to thank Blake and Luke for joining me and helping answer questions, as well as everyone who joined from the community to ask questions.
Yeah, it's been a pleasure.
Yeah, thanks. Where can folks go if they have more questions, Nicole?
We've got our Learn guides. You can also email one of the emails we put out publicly for those, which is hello@hashicorp.com. You can also find me on Twitter. My DMs are open, so you can shoot me a DM. And my email address, if you have a specific question and I can get it to the correct person, is just nhubbard, my last name, @hashicorp.com.
And we also have our discuss forums, discuss.hashicorp.com. So that's a really good place to go for resources. Sorry, Alex?
Yep, I was gonna just reiterate exactly what you were saying, Luke. There's a thread that was started for the specific office hours in the Consul category. And so what we'll do is we'll add some resources there. And if folks want to continue the conversation, they can do so in that thread.
Perfect.
All right.
Awesome. Thank you, everyone.
All right, thanks.
All right,
All right.
bye.